Hello and welcome everyone to another one of my coding videos. This time we are going to talk about the problem of transposing MIDI values in a synthesizer plugin or plugin that has a similar structure like my Hammer and Meißel plugin, which has already been released the moment I released this video, but it is still work in progress while I'm recording this video. So whatever you see here, it is not looking or sounding the way I want to release it yet. Just so you know. I want to familiarize you with the problem. So here we have a little pad and a drum break. And we have Hammer and Meißel on the drum break with the notes coming from the pad in order to harmonize the drum break. And now we might want to transpose these notes so that they are not exactly the same as on the other tracks. For example, by shifting them around in octaves. But there is no change in sound because we have not implemented the transposition yet, which is what this video is about. So what would be the most obvious solution to this problem? My initial attempt was the idea that I want to have the MIDI processing and the audio processing separated from each other. Because then the code of my synthesizer doesn't have to deal with so many things. It already has so many responsibilities. It would be nice if some of these things can already be settled at the core, just so that the code is a little bit nicer. A pure MIDI effect that can transpose notes without upsetting the upcoming audio processes. This would also be useful in case that there are multiple audio processes in series that want to work with the same transposed value, because then there is less code replication. You don't always have to add the note with the transposed value together again and again every time you pass on the MIDI. That's why I wrote this class here, Midi Transpose, which only has a MIDI buffer, and all it does is it clears the buffer and then it swaps it with the input MIDI buffer, and in between there is a loop where I'm looping through the different MIDI messages, and if they are note on or offs, I'm getting the pitch value out of it, adding my transposed in semitones value, J-limiting it between the valid numbers 0 and 127, and then I replace this value with the original note number in the message and put it into my buffer. So if we now implement this, it looks like this. We have the two parameters oct and semi-parameter here. We make a variable for the transposing value in semitones, and then we add the octaves to that. For most people, this would just mean octaves times 12, because we have 12 notes per octave. But in my case, because I implement everything as Xen harmonic, I have to have a function like this that returns the current Xen harmonic scale. And then yeah, we are calling Midi Transpose with that value. Let's check out how this performs. What? So we hear multiple problems. First of all, we don't immediately see a reaction when we move the parameter to a different value. We have to wait until the next note on values arrive. That's kind of weird. It just doesn't feel right. And secondly, notes get horribly stuck and we just have a cluster of notes after a short while. But it does kind of work. It does transpose the notes. So there is something that already works about it. We just have to improve it, right? So now I replaced the Midi Transpose 1 class with a just Midi Transpose class, and it's basically the same, but it has a note array and a retune semi member variable and an index. The note array is an array of structs with a pitch and a channel information, and it has the length 16, the number of MIDI channels, because that's also the max polyphony of my plugin. The processing function looks like this: clearing the buffer, swapping the buffer, and in the middle we have if the parameter didn't change, then we are processing the transpose value. You will see why this is important. So if the parameter changes, we are looping through all of the notes and we are sending note off values from these notes. This note array contains all of the notes that have been played, and this method still looks almost the same. The only difference is every time a message is a note on message, we're moving on with this index and we are wrapping it around at the MIDI channels, because this is basically a ring buffer. So even when this parameter changes due to the parameter changed method, the pitch values in the note array do not. So that way we get around the problem of notes getting stuck, right? Let's check it out. Yeah, this seems to work. We don't get stuck notes anymore, but it's still kind of a weird behavior because now every time we change a parameter value, there is just silence because it sends all of these node auth values and we have to wait for the next nodes to appear to hear something again. So what have we actually accomplished? There are no stuck nodes anymore. It transposes to the right values and there is an immediate reaction that we can work with and that will not confuse the listener too much, but it's still not quite nice. And also there is another problem that I haven't been talking about yet, which is how would we implement a fine-tune parameter when pitches can only be integers? We would have to incorporate pitch bend values for that, and that could get messy very quickly. So let's actually try a whole different approach. Let's throw away this thing again. And now instead of solving it on the MIDI stage, we will take this transpose semitones variable and send it directly into our modal filter. Now here we are in the processing method of the modal filter where we react to node on values and pitch wheel values. So here, this is the crucial point where we get the node number out of it and define that as our pitch. So what if we just add transpose semi to it, build. So what did we just hear? What was the difference between the last implementation and this one? It was pretty similar. We do get a correct transposition of the values and we still have to wait for the next notes to appear. But now we don't get a pause in sound anymore because there are no node auth values that are being sent. Now, is that better or worse? I would say in some way it is better because we do want to have a continuous sound, and you know, if someone decides to modulate the octave or semitone transposition value, I don't think they would want the sound to be stopped in the modulation. But waiting for the next notes to appear can still result in temporary disharmonic sounds, and also it feels a little bit weird when you turn a parameter and don't immediately hear the sound changing. So this is not done yet. Also, this is a little bit problematic because now we are back at the problem that every upcoming audio process has to do this process again. But let's just ignore that for now. Let's think about other things in a synthesizer that immediately affect the pitch. For example, pitch wheel values. Whenever there is a pitch wheel value, the pitch changes immediately, even though there might not be a new note on at the same time. That way you can apply pitch modulation within a note, and we want the transpose semi parameter to act in the same way. But transpose semi is not a MIDI message, so it cannot just be part of this else if tree. It has to be implemented differently. So in my resonator I have a little struct with a pitch and now also the transpose value and the pitch bend value. They all have default values of 0 and they can return the frequency by adding the pitch and the transposition value and the pitch bend value with a function that converts pitch to frequency according to the current Xen harmonic scale of my project. Val transpose. So the current pitch is not changing here. Calculating a new frequency, setting the new frequency, and applying the filter. Since the process hasn't even started yet, we cannot do that. Now in this method, we have to take transpose semitones out of it. We only update the pitch. Everything else still seems to stay the same, I guess. So let's run this code. Okay, that seems to work, almost. I don't want the octave parameter to go smoothly between the octave. I want it to be stepped. So let's get back to the parameters and just make sure that this value is actually rounded and the other one as well. Yeah, that sounds nice. Now we got a very distinct behavior here in this way of transposition. Now what do we got here? Now we got a perfect transposition that can definitely not have stuck notes, which is relieving. We have an immediate reaction to the parameter change. we have stepped values, we have the correct transposition values, and it's legato, so it will not struck a new note on. What do we not have? We don't have it also affecting the comp filter that comes after the modal filter right now. It has its own transpositional value, which already works. But it's independent of the other one. I don't even know if that's a problem. It could also be a design choice that every module has its own transpositional parameters that are independent of each other. But I do kind of like the way it works here in Bitwig, where you can just instantiate a node transpose module and say +2, and then all of the plugins that come here in series will all work with this transpositional value, and if you want to change it, you have to add another node transpose in between to maybe change it back to normal again. I kind of like this workflow because it's just so sequential, and I think that explains itself better than when every module has its own independent transposition. But yeah, it's still undecided, and it will also not be decided in this video. I just wanted to show you some of the basic ideas that I had around the topic of transposing values in a synth-like plugin. Let me know if there was anything that was a little bit unclear, or if you would like to specify some additional information or ideas that you had about this topic. I'm Florian Mugala from Beats Basteln, and I wish you a good time until my next video.